Hey everybody, so this is going to be a hopefully pretty quick and also pretty abstract video. Most of these videos we build something, and this one I just want to talk about ideas. I want to talk about redux, and I want to talk about array.reduce. Because I know for my part, it took me quite a while to recognize the relationship between array.reduce and state management in Redux or reducer functions, and to really understand like what that relationship is. I think it's pretty easy to see that there is a relationship. When you look at reduce, you see nums, for instance. We can make an array of numbers, and we'll just say these will be 3, 4, 17, 2, and 8, right? And thank you, VS Code. And if we wanted to get a total of these numbers, we can call reduce, and we'll pass in a reducer function, right? So this is a reducer, and a lot of us know this, that if we pass in a reducer function that, say, has values for the accumulation and the current item, then we can just return the accumulation plus the current item, and if we console.log the total, we'll get the total, right? And I think this is going to be what, 7, 24, 26, let's see, 10, 17, 34. Should be 34 on this one. Let's run it. So we'll say node reduce. And you see, there we go. We get our 34. And we know also that if we wanted to say total plus starting value, total plus starting value. So we'll have a total plus starting value. We could say nums.reduce and pass in this sum reducer. Let's actually make this into its own function. And we'll pass in the sum reducer, and we'll pass in an initial state of, say, starting value, and we'll see we'll set that to 100, and we should see that this will be 134, right? So we can pass in a starting value, and you can see now we get that starting value. If there is no starting value, of course, the starting value will be this first number in the array. And so what about when we want to update essentially what we're doing here is we're updating this starting number, right? We've got a starting value. We could call this the state of our application, right? In a sense, the starting value. And we can use reduce to update that starting value. And we'll always only get one. And we'll do this immutably, and that's why we use reducers in Redux. And that's why Redux exists, right? Is because somebody had this great idea that we could update sort of the state of an application using these reducers. So One thing that I think kind of helps a little bit in terms of abstracting this is to um, think about this reducer in in these abstract terms. Um, and so let's make a reducer that has an initial state. So we'll say initial state. So the starting value here we can instead set as an object, and it's going to have a position. If I can type it out. I don't know why I'm just having such a hard time finding that S key. There we go. So we'll have a position property on our state, and to start off with, let's just give it an X value and set that to 0. So we could say this, maybe this is the coordinates of a character or an object on the screen. And if we had a list of values, and we wanted to call, oops, there goes VS Code doing its humble magic again. We wanted to call a move reducer. Remember our signature for a reducer is going to take in state. And we can set that to initial state by default. And then we can take in an action, which in this case, let's just call that a move value. So we can maintain the relationship to these numbers. And that move value is how much we're going to increment our position each time. Now from this reducer, just like this reducer, we're going to return an object. And that object is going to be whatever the state is. And so we can actually add a Y here. And so we'll return state, and then we'll return states.position.x. We'll set that to, I'm sorry, we don't want to do that. We want to return X. And set that to state.position. Sorry, we want to return position. And we want to return an X value. And you know what? I'm going to get rid of that Y. That was silly. Because we're not going to pass in a Y. So we'll just return state.position.x plus a move value. And so when we call this move reducer, we'll pass in our move values. We'll start with our initial state, and we'll increment it. And let's just, this spread operator here, for instance, might have a value called live. Right? And so if we now take our let's just call this state equals move values dot reduce, passing in our move reducer and initial state. And let's see what we get. We should, if we log this to the console, we should see, what am I logging? I'm logging state. We should see that state will now have a position object that's going to have an x value of -3. Let's take a look. We did, and we because of this spread operator, we maintained this alive status of true, so it's going to bring the rest of our state in. And what we could do further is maybe add this y. So we'll start the y at 0, and we could say state dot position dot y, right? Because we know if we can assume that what's happening in our reducer is we're passing in x values. Now, how could we set this up so that we were a little more flexible, right? What if we don't know that those are x or y values? How can we figure that out? That's where these messages come in. So we'll say instead of just passing in a number, we can create a action that'll have a type. And then we can make our switch statement that will look for a certain type. And if that type is, let's say, move x, if that type is a move x, then we're going to want to return like this. And if that is a move y, then we can update the y value instead. So we can say, oops, I don't know why this isn't working out for me. There we go. Come on. And we'll take these and move these over. Ah. Okay, that's better. So now we've got this return. I think I have a typo. Case return, a comma. Case move x, move y. And we're going to also have a default, which will just return everything in state. So that's if there's no other values. Now, what's up there? So that's going to be can't quite figure out what I did wrong there. Return state, position. Oh, there it is. Okay, good. Now, we want to create our actions. And so instead of having these numbers here, we can say move we'll give it a type of move x and a payload of -1. And we can say for our next one, again, the type of move x and a payload of, let's just make it big, like a -10. And then for good measure, let's make a move y. And we'll give it a payload of -100, positive 100. Now let me just see, what am I doing here? There we go. That's better. Now, if we pass in those move values, we should update our x on the move x, and on our y, we'll update this. And instead of move value here, now we'll say action dot payload. We'll do that for both of those. So each one of these actions will have a type and a payload, and we'll run this with our new move reducer and our new move values, and we'll just see we should get something a little more dynamic. And there we go. We've got our x at -11 and our y at 100, and everything worked beautifully. And that's a reducer and how a reducer functions. Not only in Redux, because notice we're not using Redux here at all. We've just written a reducer in the style of Redux. Now in a further video, I'm gonna show you how we can implement, something a lot like Redux. It's not that hard, but I think I'll save that for another video where we can create a store, and the store uses reduce in it, just in a way that's really similar to what we've done here. So Redux isn't that complicated, but the key thing is to understand what is a reducer and how does that function. So I hope this video helped a little bit, and